Type 3 kinematic equations or kinematic problems are just one step even more complicated. So you have a cliff and you throw something off at an angle. And the problem with this is that a lot of the tips and tricks that you would have used in type 2, where the object lands at the same height, you can't do that so that the final velocity doesn't equal the initial velocity. So that's why these are a little bit more tricky. We don't really run into them very often. I'm going to run through a few things that you're going to need to remember, but that's about it. So just like a type 2 projectile motion where it starts and stops at the same place, we need to split our initial velocity, our v0, our initial velocity, into the x and y components. So we get our initial velocity in the x direction and we get our initial velocity in the y direction. From here, remember the acceleration in the x direction is going to be equal to 0 because after it's shot, there's nothing that's pushing or pulling on it. And the acceleration in the y direction will be equal to opposite g, or -10 meters per second squared, that gravitational field strength. From there, depending on what you're looking for, you can look like the change in y position is the initial velocity in the y direction times time plus 1/2 acceleration time squared. This in the y. This becomes a little bit more difficult because if you need to solve for time, this term doesn't drop out, and so you would have to use a quadratic. I haven't seen anything so far in any of the AP stuff that since the redesign that has you solving quadratic equations for time and then plugging them into, remember that range equation is just the initial velocity in the x direction times time. So I haven't seen that. I'm not going to have you go over these questions, but just so you know, that is how you solve a type 3 problem.